Okay, this is just a short overview of the one of the textbooks I'm recommending. It's Computational Mathematics with Sage Math. Certainly I know students when they're trying to use a computer algebra system, typically they're trying to use it for a specific purpose, not to learn the application, but for a specific purpose. So what a lot of students end up doing is just, forgetting about, trying to master something, is they're trying to find sample code that might help them out. So I'm going to say, let's hear in differential equations. Well, I just typed in DIFFER. I'm seeing it right now. So displaying solutions of differential equations. I can click on that. All right, it's going to bring me to that section of the notes. And then I see this over here. And I say, gee, that looks nice. And I wonder, how could I do that? I might scroll through this and look for code. All right. So what a lot of students do is they just simply say, oh, this is code. Let me see if I can adapt this code to the problem that I want to solve. And there's nothing wrong with that. All right. There's really nothing wrong with that. A lot of times I'll end up doing that. I'll look for code and I'll try to reuse code. But the problem is you're going to lose a lot of information by doing that. And some of the information you lose by doing that is how to fundamentally use Sage. So I'm going to make another recommendation to you. My recommendation to you is that if you want to learn this software, it's okay to search for code. I'm not saying it's not, but I would recommend that what you do here is simply read the book, right? I know that's difficult, right? So what do you mean read the book? Go back to the beginning and you start reading page by page. All right. Now, someone says this takes too much time and I'm not interested in going page by page to a book. I just want to find code. Again, that's one way to do it. And here's the deal. When you're going forward, you're going to need a skill set. And part of your skill set is going to be able to use software efficiently, not searching around for code, right? You're going to be inventing your own code at some point. All right. You're going to have problems that are not going to be listed here. All right. So, a lot of it's, basically an introduction, preface. I can't hurt to read through that. A lot of it's thanking people. And then there's this table of content, which we did talk about. It's a long table of content. And yeah, I know it's tedious to go through a book. I would recommend this for all your courses, by the way. Now, of course, the point of this is when you're reading a book, some people read a book as if it were a novel, and this is not the way to read this textbook. I would start at the beginning, though. All right. What do you mean by starting at the beginning? Getting to grips with Sage. All right. So I go through this over here. First stages, I go through, the Sage program. They talk about it. They give me some how to access Sage. They give me some nice little pictures over here with some code in it. Again, I would recommend reading through that. They talk about Sage and Python, the aims of the history of Sage, Sage is software and ecosystem. They talk about an early note that the founder of Sage wrote and why the name Sage came up. Now, typically people say Sage or Sage Math. They talk about using Sage as a simple calculator. And there's some important things being pointed out here that you really need to pay attention to, right? How do you do that? Read, all right? This beginning stuff, I'm going to say, is pretty simple to get through. And as you're reading it, I would strongly recommend that you have Sage running so you understand what some of this stuff is giving you. Does reading take time? It sure does, all right? And that's the problem. A lot of people don't have the time. They're in a rush to get their assignments done, whether they understand them or not. And typically students will only do assignments if they're for credit, which is another, shortchanging of your educations. You want to start doing things because you enjoy doing those things. All right. So hopefully you're in this course that's, typically mathematics or physics or computer science, and you're trying to learn that field so you can enter that community as a productive member. All right. So, bottom line, you go through the first steps and then you get to the second thing over here. And again, I'm going to point out what a lot of people do when they're reading a textbook, right? They read it. All right. Sometimes they don't even read it. They look at it and they point at it. They take their finger and point. They say, yeah, 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 yeah. All right. Not going to go anywhere. So I'm going to suggest reading it. But when you're reading it, you're going to see code that you may not understand what the code is. Now, what I'm going to do is I'm going to copy this code. I just copied it. I'm going to go to my Sage and I'm going to type it in. By the way, I haven't read this to you. So I'm going to hit the Enter key. And when I hit the Enter key, Sage is going to do this. And someone says, I don't know what that command is. Well, let me explain it to you. It's a Boolean, and a Boolean returns one of two things. Either the statement is true or the statement is not true, right? It says that statement's false, all right? I would recommend reading this and understand why they have this piece of code in there. So I'm going to go to the whiteboard now. If I were reading the text, what I would be doing is I would be reading the text. I'm not going to read it to you though. So I'm going to switch screens. And I want to go through what I would be doing, reading this text. I would look, whoops, I'm sorry about that. I didn't share the screen with you. Okay, I'm sharing the screen with you now. I would be reading this and wonder, what is this thing saying? So what I'm going to do is I'm going to, try to understand. I'm going to pull this on the side. It's almost like my understanding just depends on, let me get my pencil sharpened here. Let me get my copy out. I'm going to pull this on the side. I'm going to pull this over here. I'm going to push this up here. And I want to kind of understand, what is this over here? And I'm looking at it. And I got to make sense out of it myself. So I'm going to write down what I think it's going on over here. And this is why when you're reading a textbook, you need paper and pencil next to you. So you jot things down. That doesn't have to be neat, but I'll write down, I'll write down what I'm seeing. I'm seeing the arctangent. That's why I write that down. 1 plus, well, you know what? I'm just going to say the absolute value of x, ABS of x. That means the absolute value of x. I'm just going to call it A. And what do I know about A? I know A is greater than or equal to 0. The reason for that is it's easier for me to write that down. All right, so I'm going to say A with the understanding that A is greater than or equal to 0 is equal to pi over 2 minus the arctangent. Now, by the way, I put 1 equal sign down there. I want to put the double equal sign in Sage means they're saying this is an equation. And this reminds me of an identity. All right. So the Boolean over there is saying, is this an identity that's true for all x? All right. So let me keep writing that down. And what do they have here? They have 1 over 1 plus. And again, remember, A is the absolute value of x, and A is a number greater than 0. So then I got to remind myself, as I'm wondering about that. I have to remind myself about the arctan function. So I'm going to remind myself arctangent. And the arctangent function, there's asymptotes to it. And where'd you learn this in Math 120? That's y equals pi over 2. And it's asymptotic here with the y equals minus pi over 2. And what does that curve look like? It looks like this. Okay. So then the question is, what are they asking me to do? Well, the arctan of 1 plus A, right? I want to see if I can understand what that means. I want to point out 1 plus A is some number over here, right? So I'm going to say this is definitely in the domain of the problem. Now, what's it going to spit back? I'm going to just trace up, and it's going to spit back an angle theta. And that angle theta has got to be better than 0. And why is that? It's 1 plus A. So it's definitely above, let me point this out to you, definitely above this point. But I do know one thing about it. Y could be a really large number. It's also going to be less than pi over 2. So what I want to do is just kind of understand what this left side is telling me. And once I do that, I'll try to understand the right side, right? So the left side, what I'm going to do is recommend what you did in Math 120. You drew a triangle. I know my angle theta is acute. How do I know that? I just looked at my picture. And what do I know about it? I know the arctan has the ratio, well, this side's here, 1 plus A over 1. So let me put this down. The tangent of theta is equal to what? 1 plus A over 1, and that equals 1 plus A. So now I'm going to call this side over here theta. Let me put that down for you. So I'm going to call this side over here theta equals pi over 2. Now I'm going to talk about this angle over here. Now what is that angle? That angle over there, well, that's the complement. So it's going to be pi over 2 minus theta. Now what I want to write down is I want to write down the tangent of pi over 2 minus theta. And what's that going to be? Well, I'm looking at that picture over there. It's going to be the opposite to that angle, which is 1, over the adjacent, which is 1 plus a. All right. So what do I now know? Let me go back over here. I know this. I'm sorry, I forgot to put the arctangent down. So I know this now. And what is this guy over here now? Well, I'll write it down for you. It's going to be minus, whoops, I got to get the black ink out. Minus, what am I going to get over there? I'm going to get this, pi over 2 minus theta. Now, someone says, if I read a book and every page took me this much time to get through, I would never get to the end of the book. That may be true. However, over time, you're going to get much faster because you are actually actively engaged in this. Now, what do I get over here? I get theta equals pi over 2 minus pi over 2 plus theta. What do I get? Theta equals theta. So now I know this is an identity. This is an identity that's actually true for all x. All right. So now I got something to think about. And again, I haven't even read the text yet. What I did was I copy pasted code, and I'm wondering why they said that was false. Let's go back to my my notes. And I'm going to do that. And here's where you're going to start to read. Now, I want to point out when you're reading this thing is you might have to go back to more basic knowledge, right? So let's talk about more basic knowledge using Sage. So I'm going to use something a little more simple. All right. So I'm going to say bool 1, 2 minus 1. What should be returned there? A true statement. That's true, right? Let's try another one. Bool, and again, I'm learning. X divided by X is equal to 1. Now here comes a problem for a lot of students. This actually is true for all X except what X? It can't be 0. But there's a problem here. It says it's true. All right, so you know there's some subtlety here that I'm not quite appreciating at this point. And this is where reading comes into play. You want to start to read it, and they're going to talk about this, right? They're going to talk about this. Although this statement is actually true, they're going to talk about why Sage is returning a false on it, right? Now, someone's going to say, well, if Sage returns a false on something like that, which I was able to show is true for all X, why would I use Sage? You're trying to learn to use Sage in a more productive way, all right? So a lot of times you'll be typing things in that you don't truly understand. And if you don't truly understand them because you haven't read about them, it's going to be really tough to look at output, all right? I want to do one more thing for you. And what I want to do is I want to take this thing over here, and I'm going to just, maybe you're not familiar with this command yet. Maybe you haven't done much Sage yet. I'm going to say clear, and I'm going to try to solve. And I want to point out there's a point to this. And try to solve for X. What does it basically return to me? The same statement, all right? So what I'm claiming over here is that maybe I don't fully appreciate how to get Sage to solve that equation. Because really what Sage is doing, and I'll tell you what it's really doing when it's at Boolean, it's seeing if the difference between those two objects, and when I'm talking about the two objects over here, the left side of the equation and the right side of the equation, if the difference produces 0, and if it does, they would say it's true, right? So then it comes down to is maybe I'm not using Sage to the full extent, right? So I have to start to learn Sage. How do you do that? Again, reading, looking at code, typing in code, paper and pencil to figure out what's going on over here. But again, the key thing over here is reading. It's just not simply pointing and saying, yeah, yeah, yeah. You've got to spend some time on it. Now, granted, as you read through this, a lot of this stuff may be very difficult for you to comprehend, but the bottom line, like much of life, it is difficult to comprehend. It takes time. Things worth learning take time. It's not a simple training exercise. It's learning. Now, will this bode well in the future for you to learn that? Yeah, if you enter this field, it does. All right. So I'm going to say if you enter the field, it's not a bad idea to learn a computer algebra system. Um, are there other computer algebra systems out there? Of course there are. You decide, right? What I mean by you decide what software works best for you. The reason I promote Sage and this book is it's free. And I think a free is a good thing, particularly when you're in the beginning of your careers and you don't want to be spending a lot of money on something that you don't know if you're interested in or not. This is a good book for introducing yourself to Sage and all its capabilities. And Sage is a good computer algebra system that you'll be able to use at Essex, when you transfer to NJIT or Rutgers or any other four-year institution. And if you go to graduate school, it also may be used there, including if you're doing PhD research. A lot of researchers use Sage. All right, so I'm going to say that's probably enough talk about that. And, get started. And again, I'm recommending this book as a good source for information about Sage. And of course, there's other ones as well. Thank you.